So we have here our problem. So the figure here shows a water theme park plan. A company is interested in buying and renovating the water theme park area. So the company intends to build two pools, one for adults. This part here is for the adults, and one for children. So this part here is for the children. FECA is a trapezoid. So FECA is a trapezoid. This outer shape. Sector ABHG is a quadrant of a circle with center A. So what do you mean by a quadrant? So if this is your circle, this is one quadrant. So one. This is one quadrant. This is two. This is another quadrant, and this is another quadrant. So a circle has four quadrants. So if you are to extend this point or this arc here up to this point, so this will look like this here. So this is your quarter circle. So if this is a quarter circle, this length here is the radius of the circle, right? So this is the radius. Then sector AHD is an arc of a circle with center B. So where's AHD? This one, AHD. So just extend the arc again up to this point. So if I'm going to extend it here up to this point. So if this is the center up to this point, this is also the same radius as the quarter circle, right? So this is correct. So this is R and this is R also. So from the intersection of the two arcs, this line here is also the radius, right? And from this quarter circle up to this intersection, this line here is also the radius, right? So we have here an equilateral triangle. So the question is, find the cost of building the children's pool if the building cost is 15,000 pesos per square meter. So if you look, we will solve the area for this part of the pool, the children's pool, then multiply it by 15,000 pesos per square meter. So we have to get the area in square meters. So the conditions are, it is given that FE is 9 square root of 13. This is in meters. G is the midpoint of AF. So this is AF, this is the midpoint. So it follows that FG is equal to AG. So this is also radius. So this is also R. G is the midpoint of AF, and then BC is equal to CE. So this one here. And also CD is equal to 3DE. These are the conditions. Okay. So how do we solve the area of the children's pool? We can break down this adult pool into different parts. So the easiest way to do this is break it into a triangle as here. So this one here is already a triangle. So I'll just extend this line here up to here. Okay, wait. So I will extend this line here. Okay, so this is a triangle. This is a right angle, right? Okay, so I have here the triangle, a sector. So I'll solve this angle. So say if this is angle alpha, this is beta. So from this triangle, we know that this is 60 degrees, right? If all the sides are equal, so it follows that all the angles are also equal. So if this is 60, this is 60 also, right? So this is 30 degrees, okay? So the condition here is CD is equal to 3DE. And BC is equal to CE. So if we will let this, let's say this is X. So let this as X. We have CD is equal to 3X. So this is 3X. So this entire length here is 3x plus x, so this is 4x. So if this is 4x, this is also, we have CE is equal to BC, so this is also 4x. Okay? So to solve the value of x, the only known distances are 4x and 3x. But we also have this length. So what's this length equal to? So this is just from center to the arc, that is equal to radius. So if this is the radius, we have r squared is equal to 3x squared plus 4x squared by Pythagorean theorem, right? So we have r squared is equal to, wait, this is parenthesis, sorry. This is parenthesis, so we have 9x squared plus 16x squared. So we have r squared is equal to 25x squared. So we have r is equal to 5x. Okay, so after that, so the only known value is Fe, right? So maybe we can use that value to solve for x, because we have r in terms of x already. So that's it. So to solve for x, we have, if we take the trapezoid here, so this is 9 square root of 13. This is 4x. This is 5x plus 4x, right? So this is r is equal to 5x. So we have 5x plus 4x. This is 9x. And this is also r plus r. So 5x plus 5x, that is 10x. So if we are to project the line here, here. So this is also equal to 9x. If this is 10x, so this portion right here is equal to 10x minus 4x. So this is 6x. So this is 4x, right? So the entire length is 10x. Okay? So this is 6x. So we can solve now the value of x. So we have 9 square root of 13 squared is equal to 6x squared quantity. So this is in parentheses, plus 9x squared. So the value of x is equal to, if we are to use our calculator, so we have x squared is equal to 9. So we have x is equal to 3. Correct? So if x is equal to 3, r therefore is equal to 5 times 3. So we have 15. So now we can solve for the area of the children's pool. So this is the children's pool, okay? So this one here. This one here. This one here. Okay, to solve for the area of the children's pool, we have, so area of the children's pool is equal to area of the trapezoid. So we have area of the trapezoid minus this area of the triangle here, area triangle 1, or area of triangle, okay, minus area of sector 1, right, this sector here, minus area of equilateral triangle, right, then minus area of sector 2. So the only unknown here is the angle alpha and beta. So alpha is equal to inverse tangent, so opposite over adjacent. So we have inverse tangent of 3x over 4x. So don't mind substituting the x, it just cancels out. So we have alpha is equal to 36.8699, right? Now beta is equal to 180. So we have here 180 degrees minus alpha minus 60. Minus 36.8699 minus 60. So beta is equal to 83.1301. So this is in degrees. Okay? So okay, we have now to solve the area of the children's pool. So the area of the children's pool is equal to the area of the trapezoid minus the area of this triangle minus the area of this sector minus the area of this equilateral triangle minus the area of this second sector. So we have the area of the trapezoid is, the average of the height is 12 plus 30. Average, that's over 2 times 27, the base, right? So the average of the height times the base. Minus area triangle, so the area of the triangle is 1/2. So the base is 4 times 3, so that is 12. The height is 3 times 3, this one, so that is 9. Minus the area of the sector, so there is really no need to memorize the formula of the area of the sector, because the sector is just, say for example, I have here a pizza. So I have a slice. So this is your angle. So it's just the area of the circle times the angle divided by 360. You just need the area of this part here. So that is relative to the entire angle, which is 360, right? Okay, so the area of this sector is equal to area of the circle. So we have pi r squared times the angle, which is beta, 83.1301 divided by 360. Okay, so minus the area of the equilateral triangle is equal to 1/2 AB sine theta. So A and B are the same, and theta in all angles are the same. So it's just 1/2 times AB, which is r times r. So we have 15 squared. Okay, sine theta, that is 60. And lastly, the second sector. So we have here, again, this is just 30 over 360. So pi r squared, which is 15, the area of the circle, times 30 divided by 360. The answer is 193. So area of the children's pool is 193.4417. So the question is, how much will it cost for them to build the pool? So the cost would be area of the children's pool times 15,000. So we have here, so this area here, just multiply it by 15,000. So 193.4417 times 15,000 is 290,1625.5. So this is 2,901,000 pesos. Okay. Okay. So that's it. So this is your answer. Okay, thanks.